Welcome to graphing piecewise functions, and we're doing some examples. Our essential question is, how do we graph piecewise functions without a calculator? And we're going to get right into the examples. So example 1, we want to graph the piecewise function f of x is equal to 3x plus 2 if x is less than or equal to negative 2, 2x squared if negative 1 is less than or equal to x is less than 3, and negative 2x minus 1 if x is greater than 3. So first thing we're going to do is we're going to fill in our functions. You want to make a table very similar to the table that I've drawn, and you're going to work through these different pieces of the table to figure out what your points are going to be so that you can graph your function. So first thing I'm going to do is fill in my functions. So 3x plus 2 is the first one. It's going to go in the first blank. Second blank, 2x squared. Third blank, negative 2x minus 1. Next thing I'm going to do is look at my domain. The domain is represented by the statement if x is, and then some relationship to a number. So in the first one, our relationship is if x is less than or equal to negative 2. Now when I'm picking my domain values, I want at least 3, and for the first one I want to pick numbers that are less than or equal to negative 2. Now the numbers that are listed in your domains, I'm going to put a box around them. We always want to include those numbers in our domain. Even if it says less than and not less than or equal to, I still want to include it because I want to plot that point. And I'll talk more about that in a minute. So negative 2 is one of my numbers. I also want numbers that are less than negative 2, so negative 3 and negative 4. Now once I've chosen my domain values, now I'm going to plug them into the function. In other words, I'm going to show my work. So the first one I'm plugging in is negative 4. So we get 3 times negative 4 plus 2, which gives me negative 12 plus 2, which is negative 10. Second one, 3 times negative 3 plus 2, so that's negative 9 plus 2, which is a negative 7. And 3 times negative 2 plus 2 is negative 6 plus 2, which is negative 4. You can see that this is changing at a rate of 3, which makes sense because that's our slope. Ordered pair now is going to be negative 4, negative 10, negative 3, negative 7, negative 2, negative 4. Now, we should all know that this is a linear function because there's no exponent, there's no square root, it's just 3x, so this is in linear function format, so I'm expecting a line. The next thing I'm going to do is come over here and decide what kind of point it is. Now, where I'm going to start is with this value right here. This was one of my critical points up here because it's listed. It's a number that I see on the domain. So I'm going to put a box around that, and that tells me I am either going to call it a open circle or a closed circle, and how I decide that is what is the symbol that's right in front of it, or in the case of negative 1 here, what's right behind it. Less than or equal means that this particular point is going to be a closed circle, because anytime it's got that little equal bar, it's closed. So I'm going to go ahead and color that in as a closed circle. Now the other 2 points were ones that I chose. I didn't see them listed here in the domain, so those 2 are just going to be regular points. So I'm just going to put a little dot to represent a regular point. The only ones that get special points are the ones that I see listed in my domain in the original piecewise function. So now I come down to the second one, 2x squared. I'm looking for values between negative 1 and 3. So negative 1 is going to be one of my values. 3 is going to be one of my values. These are special points because they're listed in my domain, so I'm going to put little boxes around them so that I remember that. And then I'm looking for some points in between. Now because this is a quadratic, I probably want more than 3 points. Matter of fact, I'd probably like 4 or 5 points. So I'm going to go ahead and start picking some other points. I've got 0, I've got 1, and I've got 2. That gives me 5 points between -1 and 3. Once I've got those, now I'm going to plug them into the quadratic equation here, plug it into the function, see what we get. So the first one, I've got 2 times -1 squared. -1 squared is 1 times 2 is 2. So my first ordered pair is -1, comma, 2. Second one, plugging in 0, 2 times 0 squared. 0 squared is 0 times 2 is 0. So I have the point 0, 0. Now if I go to the next one, I've got 1. So 2 times 1 squared. 1 squared is 1 times 2 is 2. So you can see this one started up, this one's going down, this one's coming back up again. So you can see that quadratic format forming. Next one is 2 times 2 squared. 2 squared is 4 times 2 is 8. So my next point is 2, comma, 8. And the last one, if I plug in the 3, 2 times 3 squared, this one's going to be kind of big. 3 squared is 9 times 2 is 18. So my last point is 3, comma, 18. Now we need to determine what kinds of points they are. So 1, or -1, comma 2, this was a special point. So this one is either going to be open or closed. So I come up here and I look, because of that less than or equal, it will be a closed circle. So I'm going to put a closed circle there. The next one, the next 3, as a matter of fact, are in between points that we chose. So those are just going to be regular points when I graph it. And then the last one was one that I got from my domain up here. So 3, comma, 18 is going to be a special point, and if I look at it, there's no equal bar, so that one's going to be an open circle. So there's my open circle. So now I am ready to move on to the last one. We're looking for values that are bigger than 3. 3 is one of the values I want to use, so I'm going to choose 3, and then 4 and 5. You can choose fractions and decimals if you want to, but that gives you a lot of extra work, so I probably wouldn't. And you can pick bigger numbers if you want to, but again, the bigger the number, the harder it is to graph. So I would stick with, the smaller numbers that you can. So now we're going to substitute it in. We got -2 times 3 minus 1 is -7. The next one, -2 times 4 minus 1 is -9. The last one, -2 times 5 minus 1 is -11. And 3 was one of my special points, so I'm going to put a little box around that. And let's go ahead and fill in our ordered pairs. We've got 3, -7. We've got 4, -9. And we have 5, -11. So the last thing we need to do is fill in what kind of point it is. 3 had the greater than symbol in front of it, so that's going to be an open circle. So an open circle at 3, -7, and then the other 2 points are just regular points. Now that I have my table fully filled in, I'm ready for step 2, which is graph each function according to the chart. So I'm going to go plot these points. So I'm going to make these kind of points at those values, and then I'm going to connect them and finish my graph. So over here, I'm going to draw a little graph. Again, the last 2 columns are really what I want to see on the chart once I've filled it in. So, first point, -4, -10. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's my first point. Negative 4, 10 is down here. Next point, negative 3, negative 7, negative 3. Negative 7 would be here. And the third one, negative 4, or negative 2, negative 4. Over 2, down 4. And that one is a big point. That means it's an end point. I'm not going past that one. You do not go past it. Now the other direction is going to keep going forever, but once you get to an end point, you stop. So I've got a line that's going this direction forever. The next one, starting at 2, we're graphing the point negative 1, 2. So negative 1 up 2, that is a closed circle. It's a big one. It's an end point. The next one, 0, 0, is here. Next one, 1, 2. Now this is a quadratic, so you know that it's going to be curved like a U shape. The next one is 2, 8. So this is not, it's not a V shape, it's a U shape. 1, 2, 3, 4, 5, 6, 7, 8. And then your last one would be up at 3, 18. Which is way up here, and you're going to put a open circle at that point up there. Let me just add one more mark because that wasn't quite 18. Alright, so this is a quadratic again, so we know that it's shaped like a parabola, so it should be curved down here at the bottom. It goes all the way up to that point. Now on this one I had 2 endpoints, because if you go back to your original domain, you had 2 endpoints on your domain. So this one expects to have 2 endpoints. Last one, we are graphing starting at the point 3, negative 7. Let's do it in blue. 3, negative 7 would be here. That is an open circle. So I put my open circle. 4, negative 9. There, and the last one, 5, negative 11. One more mark, and again this one was linear if you look at the original equation with the negative slope, so we see that it's going down, and it keeps going forever. This is a piecewise function. You have the first piece, second piece, third piece. Must pay attention very closely to what kind of circle it is. Is it open or closed on the endpoints? And again, you figure that out by, does it have the equal bar? You're going to color it in. Does it not have the equal bar? It's going to be an open circle. Okay, go ahead and pause, finish writing your notes, and then we'll do one more example. Okay, welcome back. Example 2, we want to graph f of x equals x minus 2 if x is less than 1, and 4 if 1 is less than x is less than 4. So step number 1, we fill in our functions. Step number 2, we start deciding our values. So we want x is less than 1, so I'm going to use 1, and then I'm going to choose numbers that are less than 1, so 0 and negative 1 will suffice. I'm going to put a box around the 1 because it's special. Next, for the second function, I'm going to be graphing 4 if 1 is less than x is less than 4. So again, our special values, and this one is still a line because there's no exponents and no other special symbols. So we're going to be going between 1 and 4. And 3 points should suffice, so 1 and 4, and I'm just going to use 2. Alright, go ahead and pause, fill in the table, and let's see how you did. Okay, how'd you do? x minus 2 is my function. My numbers that I plugged in were -1, so -1 minus 2 got -3. So -1, -3 was just a regular point because it's not listed up here in my special values. 0 minus 2, -2. 0, -2 is my point. Again, just a regular point. And then I plugged in 1 minus 2, got -1. So 1, -1 was my ordered pair. This one was one of my critical points, so open circle is what we have because there's no equal sign. Now for the function 4, there's no x to plug into. So no matter what my x value is, I'm always going to get 4. So notice that there's nowhere to plug it in, so I just get 4, 4, 4. So my y values are just 4, 4, 4. My ordered pair, 1, 4, 2, 4, 4, 4. 1, 4 was a special point. It's one of my critical points. It's an open circle because there's no equal. 4, 4 was also one of those special points, so it's an open circle because there's no equal bar. And 2, 4 was just a point in between, which is just a regular point. Now we're ready to graph these. So go ahead and see if you can graph this and then check it in a moment. Okay, welcome back. Now time to check our graph. -1, -3, plotted here. It was a regular point. 0, -2, again, right here on the y-axis, regular point. 1, -1 was an open circle. That's an end point. The other end did not have an end point, so we have a line going through those points and going forever down to the left. Second line, 1, 4, plotted that point. It was one of my end points. 2, 4, just a regular point in between, and 4, 4 was a point on the end. Since I have 2 endpoints, I've got a segment in between, just like in geometry. And notice that this is a horizontal line because the y value is always 4. This is our piecewise function. Notice it only had 2 equations, so we only have 2 parts. If it has 3 equations, you have 3 parts. If it has 4 equations, you have 4, etc. Okay, that's it for the notes. Hope your evening goes well, and we will see you in class tomorrow.